Okay, now we need to finish section 2.1. My computer decided to take a rest in the middle of a problem. So we'll finish this section very quickly now. We were in the middle of doing this problem. Beta is 45 degrees. Find cosine and cosecant and cotangent of beta. So we'd sketched the picture of 45 degrees. The terminal side stops in the first quadrant. Well, this is one of our special triangles, right? If you have this is 45 degrees, the angle up here will be 45 degrees. What are the numbers that go on this special triangle? 1, 1, square root of 2. This one's a lot easier than the 30, 60, 90 triangle because square root of 2 is about 1.4. It's the largest number of the three, so it has to go on the hypotenuse. And then you have a 1 and a 1 on the other sides. So that's easy. Now we have the three numbers in our triangle. Now we just answer using the definitions of our six trig functions. So what's the cosine? Cosine is x over r, or adjacent over hypotenuse. That's 1 over square root of 2. Cosecant is hypotenuse over opposite, or y over, r over y. So that's square root of 2 over 1, or square root of 2. And cotangent's x over y, or adjacent over opposite. So that's 1 over 1, which is 1. Again, I'm perfectly happy with 1 over root 2. If you wanted to rationalize, you'd have to multiply by root 2 over root 2 to give you root 2 over 2. So either this is the answer they'll have in the back of the book, root 2 over 2. Okay, so we finished that problem. So that's just using the special triangles, just learning the three sides. So 45, 45, 90 is 1, 1 square root of 2. The 30, 60, 90 is 1, 2 square root of 3, where the 2 is on the hypotenuse. Okay, so the next problem says, for the triangle below, find the exact values of A and C. So here's the triangle. You have to draw that in your notes, please. It's not to scale. So this is the angle A, B, and C. C is the 90-degree angle. B is 30 degrees. And remember how we label our triangles. Angle C is opposite side C. Angle A is opposite side A. Angle B is opposite side B. So little b is 7 here. Okay. Notice the instructions say find the exact value, so no punching in the calculator and rounding. But what are we supposed to be using here to solve this problem? We want to use the ratios in the special triangles. So remember, in the previous video, what was the relationship between the sides of the 30, 69 triangle? If it helps you, you can put the 60 here. Okay, so this 7 here is playing the role of what? How is 7 going to compare to the other sides? The 7 is opposite the 30 degrees, so 7 is the small side because it's opposite the smallest angle. How did we go from the short side in a 30, 60, 90 to the hypotenuse? Do you remember? How did we go from the short side to the hypotenuse? Right? If it helps, let me draw the 30, 60, 90, the numbers we learned. Right, 30, 60, 90 was 1, 2 square root of 3. 2 is the biggest number, so it goes on the hypotenuse. 1's the smallest number, so it goes opposite the 30, and that leaves square root of 3. So the 7 in my problem is playing the role of the 1 here. How do we go from the short side to the hypotenuse in our 30, 60, 90 triangle? 1 to 2, what do? You double, right? You double. So how do we go from the short side to the hypotenuse? You double it. So C is 14. That's all you have to do, right? It's just using the special triangle and applying it to this situation, right? To go from short side to the hypotenuse, you double. To go from hypotenuse to short side, you would take half. All right, now we also need the long leg. How do you go from the short leg to the long leg in the 30, 60, 90 triangle? Well, you multiply by square root of 3, because square root of 3 times 1 is square root of 3. So what's A here? A is the short side times square root of 3. And that's all you have to do. There's no work. I mean, if you just think about the triangle and how this relates, you just, multiply by root 3. Done. Okay? So that's that one. Now the next problem is similar. Here's the picture for the next problem. Find the exact values of x and y. Okay? So this is a right triangle. One of the acute angles is 45 degrees. The length of the hypotenuse is 17, and I've labeled the two sides as x and y. Okay, this is using the other special triangle. I'm just going to use my picture that I have here since it's already here. Okay, so again, how did this again, if you want to put the 45, you can put the other angle 45 in if that helps you. Okay, so remember, how do we use this picture? This says that the two legs are the same, and how do you go from a leg to the hypotenuse, right? You multiply by square root of 2, right? And how do you go from the hypotenuse to a leg? You divide by square root of 2, right? And these two are the same. So as opposed to 3690, I went from the short side to the other two sides or vice versa. Here, I don't have to go, from there to there because I know they're the same. It's either going from a leg to hypotenuse or hypotenuse to a leg. Well, what do we have here? Here we have the hypotenuse. I want to go from the hypotenuse to a leg. So what do? You divide by the square root of 2. So y here is 17 divided by square root of 2. Again, I don't care if you rationalize or not. Well, how big's x? Well, in the 45, 45, 90 triangle, the two legs are the same. So this is also 17 over square root of 2. So this one's easier because there's only one number to remember. You either multiply or divide by square root of 2. In the 3690, there's a 2 doubling and halving and square root of 3 involved. So it's hard to keep track. Okay, so that's that one. And then the last problem here, last example. Okay, so it says consider the following triangle. Again, this is not the scale. So C is the right angle, and A and B. Okay, so little a is 5, and little c is 13, and this is little b down here. I don't know what that is. Okay. Oh, so the instructions say, for the triangle that I just drew, find sine of A, cosecant of B, and cotangent of C. Okay. Right, so for this triangle right here. Well, even before we look at trying to solve the problem, I think it's just begging for you to find side B first. We do, but I mean, theoretically you may not even need it. But I think it's just screaming for us to find B. But I hope you recognize that this is one of the Pythagorean triples I mentioned you should memorize. Remember, one of them was 3, 4, 5, and this was the other one when the hypotenuse is 13, and one was 5. The other side was 12. Do you remember that one? 5, 12, 13. Again, if you don't have that memorized, you could use Pythagorean theorem. B squared plus 5 squared is 13 squared, and solve for B, you'll get 12. Okay, so that's done. Okay, so now let's do the sine of A, cosecant B, and cotan of C. Is this one of the special triangles? Notice I didn't put the acute angles in here, so it's not apparent whether it is or not. Could this be the 45, 45, 90 special triangle? Is that possible? Well, no, because in the 45, 45, 90, the legs are the same. All right, so it can't be the 45, 45, 90. Could it be the 30, 60, 90? Think about the ratios. Okay? Remember, in the 30, 60, 90 triangle, the hypotenuse is double the short side. And 13 is not double 5. So this isn't the 30, 60, 90 either. This isn't a special triangle problem. Okay, when I say special triangle, I'm referring to 30, 60, 90 or 45, 45, 90. This is not a special triangle. It's a Pythagorean triple, one of the common ones. That's not the same thing as what I call a special triangle. Okay, so let's look at sine of A. It's kind of going back to some of the problems we did earlier, right? I'm at angle A. What's the sine of A? Here you have to use opposite adjacent hypotenuse, not x, y, and r. Sine is opposite over hypotenuse, 5/13. That's easy. Okay, now we want cosecant of B. Now we're at angle B, and what's the definition of cosecant in terms of hypotenuse, opposite, adjacent? Cosecant is hypotenuse over opposite, isn't it? So cosecant of B is hypotenuse 13 over the opposite of B, which is little b, which is 12. So we did need the 12. We didn't need the 12 in the first part, but we needed it in the second part. Okay, so that's no problem. Okay, so pause the video for a second and see if you can come up with an answer for cotangent of C. So see if you can do that, and then we'll see if we get the same answer. Okay, so if you follow along the same procedure we were just doing, what's the definition of cotangent? Cotangent's adjacent over opposite. Well, if you go to angle C here, And well, the opposite is 13, which is the hypotenuse, but adjacent, which of these is the adjacent side to C? So you might have said 5/13 or 12/13 maybe as a guess. Or maybe because of that confusion, you said the answer is undefined, which I suppose are reasonable things to put because it's confusing. Well, what's the problem here? Cotangent of C. C is 90 degrees, right? C is 90 degrees, right? Remember, we did these before. We found the trig function values for 90 degrees and 180 degrees, some of them. And what's the problem here? 90 degrees, if you go back to standard position, looks like this. There's 90 degrees. And remember, when you're doing cotangent or any trig function of a quadrantal, this is a quadrantal angle, you don't use a triangle picture. So I led you down the garden path with this by the first two use this picture because you're doing the acute angles. Cotangent of C, C is 90 degrees. You don't use the triangle picture when you're doing trig functions of quadrantals. You have to use this picture, okay? So I'm just reinforcing the idea that you don't always use the triangle pictures. For acute angles, you're good. But for a 90 degrees or 270 degrees or any of the quadrantals, don't use a triangle picture. That should have been a clue when you said, well, opposite's the same as hypotenuse and adjacent, I don't know which one to use. It's because this isn't the correct picture, okay? So here's 90 degrees, which is what C is here, 90 degrees. Again, pick the point 1 unit away from the origin. I'm using unit circle here. That's the point 0, 1. And remember, when you have a quadrantal angle and you pick the point 1 unit away, the first value is the cosine and the second value is the sine. Now, how do we get cotangent? Remember the quotient identity. Cotangent of an angle is cosine over sine. So the cosine of 90 degrees is 0. The sine of 90 degrees is 1. So the cotangent is cosine over sine, which is 0 over 1, which is 0. The cotangent of 90 degrees is 0. So it's not 5/13, it's not 12/13, it's not undefined. The cotangent of 90 degrees is 0. Right? So again, I'm being a little tricky here, but I just want to reinforce the idea. Whenever you're using a triangle picture and something is fishy, maybe you're not supposed to be using the triangle picture. If the angle's a quadrantal angle, you shouldn't be using a triangle picture. Okay, so that's the end of that section.